Way out in interstellar space, humanity's most distant messenger wanders through the universe.
3, 2, 1. MDS, we have ignition, we have a liftoff.
Launched way back in 1977, NASA's Voyager 1 is remembered as one of the greatest achievements in exploration. The mission not only transformed our knowledge of Jupiter, Saturn, and their dozens of moons, it also gave us our first close-up look at the strange and wondrous planets Uranus and Neptune. Even when you're watching this video, the two Voyager probes are still operating and traveling into interstellar space where no spacecraft or anything else touched by human hands has ever gone before. However, on track to conquer the new territory, there's something terrifying is happening on board one of the most iconic NASA spacecraft of the 20th century. It catches spooky signals from interstellar space. Does Voyager just encounter an unknown force? If so, are those signals messages aliens sent to us? But could it be a friendly greeting or a threat? Join us as we dig deep into the Voyager's unimaginable trip and the puzzling signal that has overwhelmed scientists. In the decades since the two craft were launched into space, Voyager 1 has traveled more than 15 billion miles, while Voyager 2 has hit the 12 billion miles mark. It's worth pausing to reflect on the vision that inspired Voyager, its greatest achievements, and its enduring legacy. How the two probes and their findings inspired those that followed, and how they continue to influence NASA missions today. In some quieter moments, we think about a time, billions of years from now, when our sun has become a red giant. By then, Earth will no longer be habitable, and, in order to survive, humans will have left the nest for another home, following a path forged by the Voyager missions. It's humbling and inspiring to think that, even then, the Voyagers will still be Earth's ambassadors. Each one a time capsule from an era when audacious explorers on our pale blue dot reached out to the stars beyond our solar system. Not only has the science produced by the Voyager mission been captivating, the probes themselves captured the world's imagination by each carrying a greeting for extraterrestrial civilizations in the form of the Golden Records. While Pioneers 10 and 11 each carried small metal plaques detailing their origin and date of launch, the Voyager's Golden Records were considerably more ambitious. The twin phonograph records brim with images and sounds that provide a snapshot of the diversity of life and culture on Earth to anyone that might discover them. As Carl Sagan noted, the launching of this bottle in the cosmic ocean says something very hopeful about life on this planet. But the Voyager mission was as ambitious as it gets. Collectively, the Voyagers visited more planets, discovered more moons, and imaged more places than any other spacecraft in NASA history. One of the questions many often asked is, why were there two Voyagers? In fact, Voyager was an early NASA mission, at a time when flight systems were known to suffer many anomalies that would put them in safe mode, a condition that typically shuts down all science instruments and looks for commands from Earth. Since the Voyager missions were flybys, anomalies that would require a lot of time to diagnose and correct could result in us missing an encounter and all the science that might derive from it. By having two spacecraft, we could increase the odds of the mission's success. The same strategy was employed with the Mars exploration rovers, Spirit and Opportunity. Having two rovers not only provides a redundancy, but also gives us a bigger margin for error. It quickly became clear that this 1-2 punch strategy was the best one to adopt. Voyager 1's scan platform, the swivel that moves its cameras and instruments from side to side, became stuck for several weeks in 1978. The same platform became stuck on Voyager 2's as the spacecraft was pulling away from its closest approach with Saturn. Fortunately, Voyager 2 produced fantastic results at Saturn despite the technical problems, but the anomalies reinforced the value of redundancy and having a second craft as a backup. Over their grand tours of the solar system, the Voyagers took tens of thousands of images and measurements that significantly changed our understanding of the outer planets. At Jupiter, they gave us our first detailed ideas of how the planet's atmosphere moves and evolves, showing that the Great Red Spot was a counterclockwise rotating storm that interacted with other, smaller storms. They were also the first missions to spot a faint, dusty ring around Jupiter. Finally, they observed some of Jupiter's moons, discovering Io's volcanism, finding the linear features on Europa that were among the first hints that it might have an ocean beneath its surface, and granting Ganymede the title of largest moon in the solar system, a superlative that was previously thought to belong to Saturn's moon Titan. Next, each spacecraft flew past Saturn, where they measured the composition and structure of Saturn's atmosphere, and Voyager 1 also peered into Titan's thick haze. Its observations led to the idea that Titan might have liquid hydrocarbons on its surface, a hypothesis that has since been verified by other missions. When the two missions observed Saturn's rings, they found the gaps and waves that are well known today. Voyager 1 also spotted 3 previously unknown moons orbiting Saturn: Atlas, Prometheus, and Pandora. After this, Voyager 1 headed out of the solar system, while Voyager 2 headed toward Uranus. There, it found 11 previously unknown moons and 2 previously unknown rings. Many of the phenomena it observed on Uranus remained unexplained, such as its unusual magnetic field and an unexpected lack of major temperature changes at different latitudes. Voyager 2's final stop, 12 years after it left Earth, was Neptune. When it arrived, it continued its streak of finding new moons with another haul of 6 small satellites, as well as finding rings around Neptune. As it did at Uranus, it observed the planet's composition and magnetic field. It also found volcanic vents on Neptune's huge moon Triton before it joined Voyager 1 on the way to interstellar space. For those who don't know, interstellar space begins at the heliopause, where the solar wind, a flow of charged particles released by the sun, is too weak to continue pushing against the interstellar medium, and the pressure from the two balances out. Voyager 1 left the heliosphere in August 2012, popping free into interstellar space. The discovery was made public in a study published in the journal Science the following year. The results came to light after a powerful solar eruption was recorded by Voyager 1's plasma wave instrument between April 9 and May 22, 2013. The eruption caused electrons near Voyager 1 to vibrate. From the oscillations, researchers discovered that Voyager 1's surroundings had a higher density than what is found just inside the heliosphere. It seems contradictory that electron density is higher in interstellar space than it is in the Sun's neighborhood. But researchers explained that, at the edge of the heliosphere, the electron density is dramatically low compared with locations near Earth. Researchers then backtracked through Voyager 1's data and nailed down the official departure date to August 25, 2012. The date was fixed not only by the electron oscillations, but also by the spacecraft's measurements of charged solar particles. On that fateful day, which was the same day that Apollo 11 astronaut Neil Armstrong died, the probe saw a 1,000-fold drop in these particles and a 9% increase in galactic cosmic rays that come from outside the solar system. At that point, Voyager 1 was 11.25 billion miles from the Sun, or about 121 astronomical units. 1 astronomical unit is the average Earth-Sun distance, about 93 million miles. But interstellar space, the space between the stars, isn't just empty space. There's a lot of stuff out there. Roughly 70% of the interstellar space is hydrogen. Helium makes up about 28%, formed in the Big Bang that set our universe into motion. The other 2% of stuff in interstellar space is heavier gases and dust, consisting of the other elements made inside stars and spewed into space by supernovae. The material in interstellar space is very spread out. It's denser in some places than in others, but a typical density is about 1 atom per cubic centimeter. Still, even the most dense regions of interstellar space count as vacuum compared with our earthly air. Our sun controls the conditions around our solar system, but outside of that is interstellar space and all that it contains. Astronomers call this space between the stars the interstellar medium. The interstellar medium is where stars are made. Without it, we wouldn't exist. If there weren't thick and thin spots that condensed into thicker patches that eventually became stars, the whole universe would just be a cloud of boring, cold, lifeless gas. The thick parts of the interstellar medium are called molecular clouds, often referred to as stellar nurseries, the places where stars are born. The first stars didn't have planets because there weren't any materials in interstellar space beyond hydrogen and helium. But over the billions of years of our universe's history, that has changed. It changed because stars themselves make increasingly more complex elements in their interiors. When the most massive stars grow old and die, they explode as supernovae, releasing their elements into interstellar space. Thus, it has become possible for stars to form with planets, and for at least one planet we know of, Earth, to harbor living things. Given the contents of interstellar space and process by which stars and planets are born, it seems highly likely that other planets have living things too. This is also why scientists were extremely excited when Voyager flew beyond the heliopause and became the first human-made object to explore this new territory, where no spacecraft, or anything else touched by human hands, has ever gone before. In there, scientists expect the greatest space explorer could answer the long-standing question that has captivated human imagination for centuries. Are we alone in the universe? In the thousands of years humanity has been contemplating the cosmos, we are the first people to know one thing for sure. The stars beyond our sun are teeming with planets. They come in many varieties, and a good chunk of them are around the size of Earth. However, like most scientific questions, getting an answer to this one just breeds more questions. Which, if any, of these exoplanets harbors some form of life? How quickly does life get its start, and how long does it last? The universe's eerie silence has its own name, the Fermi paradox. Physicist Enrico Fermi famously posed the question, where is everybody? Even at slow travel speeds, the universe's billions of years of existence allow plenty of time for intelligent, technological life forms to traverse the galaxy. Why, then, is the cosmos so quiet? Meanwhile, exoplanet discoveries over the past 2 decades have filled in a few of the terms in the much-debated Drake equation, a chain of numbers that might one day tell us how many intelligent civilizations we can expect to find. Most of its terms remain blank: the fraction of planets with life, with intelligent life, with detectable technology, but the equation itself suggests we might one day arrive at an answer. It feels at least a little more hopeful than Fermi's silence. We stand at a crossroads in the search for life. We've found thousands of planets in our Milky Way galaxy, a large fraction of them in Earth's size range and orbiting in their star's habitable zones, the distance from the star at which liquid water could exist on the surface. We know the galaxy likely holds trillions of planets. Our telescopes in space and on the ground and our remote sensing technology grow ever more powerful. Yet so far, the only life we know of is right here at home. For the moment, we're staring into the void, hoping someone is staring back. Since flying into interstellar space, Voyager 1 has sent back a variety of valuable information about conditions in this zone of the universe. Its discoveries include showing that cosmic radiation out there is very intense, and demonstrating how charged particles from the sun interact with those emitted by other stars. The spacecraft's capabilities continue to astound engineers. In December 2017, for example, NASA announced that Voyager 1 successfully used its backup thrusters to orient itself to talk with Earth. The trajectory correction maneuver thrusters hadn't been used since November 1980 during Voyager 1's flyby of Saturn. Since then, the spacecraft had primarily used its standard attitude control thrusters to swing the spacecraft in the right orientation to communicate with Earth. As the performance of the attitude control thrusters began to deteriorate, NASA decided to test the trajectory correction maneuver thrusters, an idea that could extend Voyager 1's operational life. That test ultimately succeeded, and in an unimaginable finding, the Allen Telescope Array in California detected signal from the Voyager 1 probe, the NASA satellite launched 46 years ago that is currently speeding toward the outer edges of the solar system, way beyond the orbit of Pluto. Allen Telescope Array, a recently refurbished radio observatory near San Francisco in California dedicated to the search for extraterrestrial life, made contact with the Voyager 1 probe using 20 of its 42 dish antennas, which are each over 6.1 meters wide. The telescope recorded 15 minutes of data, according to a statement, which were stored on a disk. The statement didn't provide any additional information about the signal it caught, but many strongly believed that there has been an encounter between the spacecraft and some mysterious force in space. One of the horrifying scenarios outlined also said that aliens had hijacked Voyager 1, and the signals it sent back to Earth were messages that higher civilizations wanted to send to humans. But will it be a friendly greeting or a threat? We just don't know. So, let's be cautious. Anyway, space is full of mysteries and surprises, so be prepared for the worst situations. Back to Voyager 1, currently located about 15.1 billion kilometers away from Earth, 162 times the Sun-Earth distance, the probe is still being tracked by NASA's Deep Space Network, sending a meager 160 bits per second of data back home. For comparison, a regular home broadband connection is measured in megabits per second, that is millions of bits per second. However, all Voyager's instruments are powered by a device that converts heat from the radioactive decay of plutonium into electricity. But with the power output decreasing by about 4 watts a year, NASA has been forced into triage mode. A few years ago, the mission's engineers turned off the heater for the cosmic ray detector, which had been crucial in determining the heliopause transit. Everyone expected the instrument to die. The last 2 Voyager instruments to turn off will probably be a magnetometer and the plasma science instrument. They are contained in the body of the spacecraft, where they are warmed by heat emitted from computers. The other instruments are suspended on a 43-foot-long fiberglass boom. And so, when you turn the heaters off, those instruments get very, very cold. So how much longer might the Voyagers last? Just a couple of few years. If everything goes really well, maybe we can get the missions extended into the 2030s. It just depends on the power. That's the limiting point. The only piece of good news is even after the Voyagers are completely muted, their journeys will continue. In another 16,700 years, Voyager 1 will pass our nearest neighboring star, Proxima Centauri, followed 3,600 years later by Voyager 2. Then they will continue to circle the galaxy for millions of years. They will still be out there, more or less intact, eons after our sun has collapsed and the heliosphere is no more, not to mention one pale blue dot. At some point in their travels, they may manage to convey a final message. It won't be transmitted by radio, and if it's received, the recipients won't be human. The message is carried on another kind of vintage technology, 2 records. Not your standard plastic version, though. These are made of copper, coated with gold, and sealed in an aluminum cover. Encoded in the grooves of the golden records, as they are called, are images and sounds meant to give some sense of the world the Voyagers came from. There are pictures of children, dolphins, dancers, and sunsets. The sounds of crickets, falling rain, and a mother kissing her child, and 90 minutes of music including Bach's Brandenburg Concerto No. 2 and Chuck Berry's Johnny B. Good. And there is a message from Jimmy Carter, who was the U.S. president when the Voyagers were launched. We cast this message into the cosmos. We hope someday, having solved the problems we face, to join a community of galactic civilizations. This record represents our hope and our determination, and our goodwill in a vast and awesome universe. The records were designed to last, meant to survive perhaps 1 billion years in space. Beneath the golden sheen is a protective aluminum casing, and below that, the engraved copper discs themselves. But to truly understand how long these objects may survive, you have to know what conditions they'll experience, and that means knowing where they will be, because there are few phenomena that could actually act to damage the spacecraft. It's a grim scenario. Dust pounding into the Voyagers at a speed of a few miles or kilometers per second. As Nick Oberg, a doctoral candidate at the Kaptein Astronomical Institute in the Netherlands, said, "The grains will act as a steady rain that slowly chips away at the skin of the spacecraft. A dust grain, only 1/1000th of a millimeter across, will still leave a small vaporized crater when it impacts." Voyager 1's vertical oscillations mean that spacecraft will spend more time above and below the plane of the galaxy, where the clouds are thickest. Oberg and his colleagues simulated thousands of times over the paths of the 2 spacecraft and their encounters with the dust clouds, modeling the damage the golden records would incur along the way. That work also requires taking into consideration the possibility that a cloud's gravity might tug at one of the Voyager's trajectories, Oberg said. The clouds have so much mass concentrated in one place that they actually may act to bend the trajectory of the spacecraft and fling them into new orbits, sometimes much farther out, sometimes even deeper toward the galactic core. Both golden records have good odds of remaining legible, since their engraved sides are tucked away against the spacecraft bodies. The outer surface of Voyager 1's record is more likely to erode away, but the information on Voyager 2's record is more likely to become illegible. And according to Oberg, the main reason for this is because the orbit that Voyager 2 is flung into is more chaotic, and it's significantly more difficult to predict with any certainty of exactly what sort of environment it's going to be flying through. But despite the onslaught and potential detours, Oberg concluded that both golden records are highly likely to survive at least partially intact for a span of over 5 billion years. After those 5 billion years, modeling is tricky. That's when the Milky Way is due to collide with its massive neighbor, the Andromeda Galaxy, and things get messy. The orderly spiral shape will be severely warped and possibly destroyed entirely. The Voyagers will be caught up in the merger, with the details difficult to predict so far in advance. Meanwhile, the vicarious sightseeing continues. Oberg and his colleague calculated that in this 5 billion year model-friendly period, each of the Voyagers likely visits a star besides our Sun within about 150 times the distance between Earth and the Sun, or 3 times the distance between the Sun and Pluto, at the dwarf planet's most distant point. Precisely which star that might be, however, is tricky. It may not even be a star we know today. As Oberg explained, while neither Voyager is likely to get particularly close to any star before the galaxies collide, the craft are likely to at least pass through the outskirts of some star system. The very strange part is that that actually might be a system that does not yet exist, of a star that has yet to be born. Such are the perils of working on a scale of billions of years. From here, the Voyager's fate depends on the conditions of the galactic merger. The collision itself might kick a spacecraft out of the newly monstrous galaxy, a 1 in 5 chance, he said, although it would remain stuck in the neighborhood. If that occurs, the biggest threat to the golden records would become collisions with high-energy cosmic rays and the odd molecule of hot gas, Oberg said. These impacts would be rarer than the dust that characterized their damage inside the Milky Way. Inside the combined galaxy, the Voyager's fate would depend on how much dust is left behind by the merger. Oberg said that may well be minimal as star formation and explosion, both slow, reducing the amount of dust flung into the galaxy. Depending on their luck with this dust, the Voyagers may be able to ride out trillions of trillions of trillions of years, long enough to cruise through a truly alien cosmos. Such a distant time is far beyond the point where stars have exhausted their fuel and star formation has ceased in its entirety in the universe. The Voyagers will be drifting through what would be, to us, a completely unrecognizable galaxy, free of so-called main-sequence stars, populated almost exclusively by black holes and stellar remnants, such as white dwarfs and neutron stars. It's a dark future. The only source of significant illumination in this epoch will be supernovas, that results from the once-in-a-trillion-year collision between these stellar remnants that still populate the galaxy. Our work, found on these records, thus may bear witness to these isolated flashes in the dark. That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time.